All right, welcome back. Today we are looking at how we can add fractions with unlike denominators as we transition away from adding with fraction circles. So up until this point, we've been doing a lot of stuff with fraction circles to help represent our thinking. So for example, if I was doing 2/3 plus 1/4, I could have my fraction circle. I'd have my 1/4, and then I would have my 2/3 as well. And then I would kind of say, like, what fraction could I use that would represent both of those pieces? Because right now, and this is why we need a common denominator, is because I have two separate colors, I have two separate pieces, and I want to be able to express my fraction with just one fraction, this problem. So we need to find a common denominator. So what we talked about in class is that you could take each of your denominators and list out its multiples. So for example, if I count by threes, I have 3, 6, 9, 12, 15. And then my fours would be 4, 8, 12, 16. And I only have to go as far that I have a common denominator. So in this case, it's 12. So what that's telling me is that I can split fourths into 12ths, and I can split my thirds into 12. So if I have 1/4, and I think about what can I multiply it by in order to get 12, it would be 3. So that's telling me I can take that fourth and separate it into 3 parts, which then instead of 1/4 means I have 3/12. And then my 2/3, I can do that same thing. But now I'm going to say what times 3? It's going to be 12. In this case, it's 4. So that gives me a total of 8/12. So then what I can sit there and do is I can show that. And now when I add, I have 3/12 plus 8/12. Or if I look over here, I have 11 pieces all together, and each of those pieces happens to be 1/12. So our answer would be 11/12. So let's look at another one. What if I have 3/5 plus 2/3? Once again, now if I'm moving away from the fraction circles, first thing I can do is I can estimate, right? So I know that 3/5 is about 1/2. 2/3 is also about 1/2. So this would give me an answer of close to 1. Both of these are over half though, so I know that my answer should be greater than 1. I'm going to go ahead and find a common denominator. So I have 5 and 3. So in this case, I have 5, 10, 15, 20, 3, 6, 9, 12, 15. At this point, I can stop because I see that they both have 15. So now what can I multiply by 5 to get 15? Is 3, but if I do it to the denominator, I have to do it to the numerator. So 3/5 is the same as 9/15. 2/3 I'm going to multiply by 5, which gives me 10/15. And now when I add those two, I have 19/15. And now it comes to that idea of how do we change this? Because many of you will notice it's an improper fraction because our top number happens to, which right here, our numerator, happens to be bigger than our denominator. So since 15 is our denominator, it tells us how many it takes to make a whole. So with 19/15, we have enough to make one whole. And when we take that whole away, we have 4 left over. So this would be the same as 1 and 4/15. Now obviously this isn't the only way that you can create a common denominator. Some of you might also find the method kind of like what some would call the butterfly method to be something that you would want to use. So with that, if I have, say, 1/2 plus 5/7, what you can do is we're going to kind of multiply this way. So 7 times 1 would be 7. 2 times 5 would be 10. And then what I suggest doing here is then 2 times 7 gives us 14. So same concept, just a different way to record our thinking. I try to advise people not to use this one as much just because I think it's easier to get lost, but it is a method that works, and I know for some people it's what you need. So I'm going to add 7 plus 10 gives me 17. Denominator stays 14 because that's our equivalent parts that we're breaking it into. 14 can go into 17 once with 3 left over.